But well, welcome everyone. Welcome everyone who is in person. Thanks to the invited speaker and to everyone who could make it to Riga, and also to the people who are joining from all over the world. I'm here just to start the event today, giving you a little bit the flavor of the quantum ecosystem to set up the basis for everyone. I'm gonna talk about my career, what we do at Kureka, and it's really good that we are doing this because well, I met Aurel and I was already in person. I must say that I'm proud of that. But it's really the kind of the came together with different ideas that we have done in quantum education over the years. So it's really an amazing milestone to achieve this today. And I think you already heard about the project. Thanks the EIT Tech Talent and the University of Latvia for the opportunity today. So what I'm gonna be covering today is a little bit my career path, what we do at Kureka and why we are doing this. And then I'm gonna give you that kind of overview of the quantum technologies ecosystem, the workforce, and some tips about your career. I don't know who you are and what you are doing. It will be good if you can fill up maybe put it in the chat, who you are, where you are from, and what you're looking for in the quantum ecosystem. Because that's really, I think, what we want to discuss today. At the end of the day, it's a little bit not only about the skills, gaining skills through training, but how this training can help us really start the quantum workforce that is so needed in this ecosystem. I don't know if you have seen this image in the past, but this is done by Gartner. This is a big consulting company. And over the years, they always do this every year where they say, these are the new technologies coming, and all the new technologies are going through this cycle. This is called the hype cycle. And what it means is that when new technologies are starting to appear, people get motivated. Governments and investors, they start to put money, but they expect a lot. And when we talk about quantum technologies and especially quantum computing, what is happening in the last year is that people expect that quantum computers are going to be ready tomorrow, which we know is not the truth. So people start being motivated, but then start to lose a little bit that motivation. And you might have heard of the quantum winter coming and all these things. But don't worry, all technologies during history have gone through this. It's like they are gonna come, and at one point they will really come and changes in our society. The important thing about emerging tech is because it's so new, the same thing with AI, we don't know what is gonna happen. It's gonna be a revolution so destructive that there are a lot of unpredictable consequences out of that. We could think of use cases, and I think a lot of people, a lot of students from our course in the projects, they have been thinking a little bit outside the box. What could we do with quantum? What could be quantum games? What could be the use cases and applications? But there is still so much to do. So the very first thing here is we are early. There is a lot still to be done, and it's going to be really changing all our societies and our businesses. Now, think about any ecosystem in general, how it works when you have new emerging tech coming. You have the scientists, academics, they do the research, they develop new products, that it will create a new industry. The industry that is already there, the different business sectors will need to use this technology because it's going to be necessary and needed for the new era in the businesses. Then you have the government. The government needs to put the money into the research to be able to do all this. And then you have the general public. People, your families that are reading the newspapers and they see quantum and they say, you are working in quantum, right? You probably have heard that. Now, what is different when we talk about the quantum technologies ecosystem is that when we say quantum, people put very strange faces. They get scared. They think that is very difficult and they will never understand. It's kind of, or sometimes they actually get super motivated with that. They say, I was reading this thing, I was watching these videos in YouTube about science. A lot of people like science. I think a lot of people don't really admit that they love science. But it's true that when we talk about quantum technologies, quantum mechanics, there is a little bit this additional connotation that make this weirdness come into place. But the truth is that when we are talking about quantum technologies, we need to a little bit go away from that weirdness and start talking the same language. The academic should be able to speak with the industry should be able to understand the academics, the government should be able to understand, to put money into this, and the general public, not something that is weird, but that everyone can understand. And that's where actually Kureka comes into place. And is how can we bridge that language gap that everyone speak quantum the same way? How I came with all this, a little bit going through my career path very quickly. I'm an aerospace engineer. I'm not a physicist from the beginning, which I think is important for any one of you who would like to change careers. I went to a lot of different countries. I did different things, but as an aerospace engineer, I ended up working as an aerospace engineer. And I moved to Germany and I worked for Airbus. I was in different positions. I did different things in Germany and in France. And it's true that my career was going pretty well in the business world. But, in the free time, I wanted to learn more things about our universe. And I started to think about what I could do. And I did one, what it was called postgraduate master that I could be doing in Germany on medical physics. That kind of introduced me the world of quantum physics thanks to magnetic resonance imaging. I wanted to learn more about quantum and decided to quit all my career in business and industry. And I got, after almost 2 years that I decided to change my career, I got a chance to move to Strathclyde in the University of Strathclyde in Glasgow in Scotland. So I went even more north and I did the 1 year master's of research and then my PhD in quantum optics, quantum simulation. But the truth is that each of these steps, it takes time. It's not that you want to go into quantum and you want to get a job in quantum tech tomorrow and it's going to happen tomorrow. All these things take time. And sometimes when people are coming to me and say, I'm looking for a job, what can I do? Don't think that if it's not coming a job in 1 month, maybe you need to wait 1 year, 2 years. Again, it's the beginning of all that. And going back to what I told you before, because I was coming from industry and I went to academia, I realized that they were speaking a different language. Academics trying to explain quantum to the businesses, that didn't work because the business don't want to go into the technical details. They want to understand the use cases and the applications of that technology. And I realized that being able to understand both languages and being part of a lot of initiatives at the government level, etc., doing a lot of outreach for the public, that gave me a very strategic position to be able to, thanks to a fellowship in 2019 from Optica. They called me the Quantum Ambassador, and I founded Kureka in 2019. Since the beginning, the aim was that we speak quantum. It was kind of bridge that language gap. You probably have seen this image of the map. I'm going to show you later in bigger. That was done from the very beginning. We wanted to understand the players in the ecosystem. We have done a lot of fantastic work and over the years, nothing very global. We have been working with big companies, with governments at different levels. We have done a lot, mainly with a focus on quantum education, but also trying to bring that ecosystem into place. And for that, you can imagine that Kureka has 3 pillars: training and education, the business consulting part, and then the community building. That is really about offering those links and those bridges between communities. We launched our online platform for courses in 2019-20, and just over the pandemic, and we started already with online courses then, and then we have grown our offer of content over all these years. But also since the very beginning, it was about creating community by organizing events, and we kind of starting being looking at different regions in the world where quantum was a little bit behind, and starting to say, let's do something about it. We created Quantum Latino and organized 3 or 4 editions of it. And in 2023, already with QWorld, we started working together by organizing Quantum Eastern Europe. And that was virtually because it was during the pandemic. So you see, all this journey of working with QWorld has been really, really fun and has grown over the years. But quantum community creation is a key thing, because otherwise we cannot really expand what we are doing. And we work with a lot of different people. For example, there is this company SpinQ that they have this quantum computer with 2 qubits, and we try to work together to expand education using this. And obviously, we have the adequate program and project that we are talking about here, and today is the event talking about that. So it's really a pleasure that we see all these things coming together. We are also the coordinators of QT Indu, that is a European project about short courses for industry, where we're trying to bring more awareness about quantum for industry all over Europe. And it's ending at the end of this year, but you will see that a lot of courses that we do for QT Indu are available as well in our platform, the same place where you can find the adequate course. This is our website, and there you have a lot of things for free if you are interested about learning more. You will have the overview about PhDs and masters in quantum all over the world. You will have some ideas of use cases for quantum technologies. You will have access to different papers, and you will have the access to our catalog that, as I said, there are a lot of things that they are free courses, like the adequate course and other courses from QT Indu. There are games that you can buy. There are different things, free or not free, but we work together with other people who are building that quantum education, those quantum education activities around the world. And I invite you to check a little bit more if you're interested. And they are, again, from small board games to big experimental labs to learn about quantum tech. That's about me and about Kureka. Now I'm going to tell you more about the quantum ecosystem. You probably know the quantum phenomena. I think more or less everyone here, I expect that you understand the different phenomena that happens at the scale of quantum. When I do this talk for people that are not technical at all, I start by telling them that, do you know what physics is? Do you know the scale of quantum? You know that you need to go to the things that are very, very small. So you need to go to that scale to understand that there are specific phenomena that you don't find in our macroscopic scale. As I said, I cannot be in two places at the same time, at least not yet. But the truth is that using the control of those phenomena, we already have quantum technology available for decades, because we have computers where we use transistors. Thanks to a lot of electrons that go through these transistors, we have lasers where a lot of photons are collimated in one direction. We have magnetic resonance imaging where we look at all the atoms in the water molecules in your body. So there are a lot of things that we already do regarding the control of the phenomena of quantum technology, to create quantum technology. So what is actually new when we are talking now about quantum technologies, like a new thing, like people call it quantum technologies 2.0 or the second quantum revolution? The difference is that if before there were a lot of atoms, there were a lot of photons, there were a lot of electrons, it was a collective effect of those particles together. Now we are looking at the control of the single particle level. We take one atom, we take one photon, and we control those phenomena that I just mentioned: superposition, entanglement, tunneling. And then we can create, based on that control at the individual single particle level, new technology. So the present is quantum, but the future is quantum, and not just quantum computing. Even though the adequate course is about quantum computing, we know that there are other technologies out there: communication, simulation, and sensors. And I'm gonna go a little bit more into detail. But it's important because quantum technologies is really vast. There's a lot of different tech, it's software and it's hardware, and depending on the skills that you will acquire doing your master's or your PhD or even an internship, that will give you a multidisciplinary approach to apply this to find a job in the quantum market. And I think this is very, very important, because we are going from you study a PhD that is in quantum algorithms and that's the only thing you can do, to maybe, and I just heard from someone who was very fundamental science approach, looking at quantum simulation. He actually changed to theory of quantum cryptography. So there are these kind of bridges sometimes depending on the skills that you acquire. And I mentioned in this because at the end of the day, today is all about careers in quantum. So going a little bit more into detail through each of these technology, Quantum computing is about using qubits instead of bits of information. Instead of zeros and ones, we have a superposition of being between 0 and 1. And it's not 0 and 1 at the same time. It's that you can be in any place between 0 and 1. If you remember the representation of the block sphere, that means that instead of just being up and down, you could be at any point in your sphere. And that superposition gives you an exponentially more power for your computations that you can do. So it means that instead of doing one operation and then another operation and then another operation, that this is what is happening in your computers now, you will be able to do more computations simultaneously. And that gives you much more power, much more exponentially able to process calculations that you could do for very difficult problems. So you will be able to solve problems that you cannot solve today, solve problems faster than today. And obviously, because again, this is new, remember the very first thing that I mentioned, a lot of things still that we don't know what is going to happen. And I think that's the beauty of quantum computing. There are already a lot of use cases, a lot of potential applications of quantum computing, but then the question is, what other things could happen in the future? And it's true that from the beginning and over the years, the very first application has been looking at optimization problems. Because you are, by this superposition, you are looking at trying to optimize operations. And it could be in pharma, it could be in manufacturing, in oil and gas, financial services. There are a lot of banks have been looking at different use cases over the last years, energy, and even in healthcare. And I really like this use case where in Canada, they were looking at the optimization of looking at the patients' beds for hospitals, how to optimize that during COVID. So there are a lot of different applications out there, and I think QWall has done a fantastic work on that. But there are a lot of opportunities and hackathons where actually the output is looking at other potential applications of quantum computing. Then quantum simulation for me is a little bit like quantum computing is the digital part of computation, and quantum simulation is the analog part of it. We are trying to simulate kind of a one-to-one model of matter. If we want to simulate 10 atoms, you put 10 atoms in your lab and you try to understand the physics of that. And if you put together digital quantum computing with analog quantum computing, that is quantum simulation, we could imagine a future where we look at understanding much more better the different properties of materials. So maybe we can develop new materials at the quantum level. If we understand high temperature superconductor, maybe in the future we can develop materials, let's say, a la carte, no? Depends on exactly what we want. And this is the part that is going to be disruptive. It's the fact that you can understand protein folding to be able to design antibiotics much better, but also the fact that thanks to quantum computing, you are going to be able to do things much faster. So again, these kind of difficult problems, impossible problems, and all these disruptive things that are going to be possible at one point. And then put together AI, quantum machine learning, and quantum computing. Then you are going to be able to manage a lot of data. Then you can process that data much faster. And all that together is really the disruptive part of all this. When this is going to happen, I'm not going to say anything. It's not going to be tomorrow, that's for sure. But what we are doing with all what we do in Cureka, in QWall, and in all these initiatives is to start preparing society, individuals, students, universities, as well as governments and businesses around the world, so that they understand what is coming. AI has come, it has changed everything, and people were not really prepared. So here, because the disruption is going to be much, much bigger, how can we start preparing a little bit earlier? And quantum sensors is kind of I think the unknown part of quantum technologies. People really focus on the communication, the security part, or the quantum computing, but they don't look at the sensors part. When we are thinking about a sensor, we are measuring something. We are measuring a physical property. With quantum sensors, using again that control of the quantum phenomena, we are going to be able to measure things much better, or measure things that right now we cannot measure. And that gives us specific use cases that are, I think, unbelievable. And I'm just going to give you a couple of them that I always like to mention. There is this one, why there is a cow there. There is a very interesting project that it was done in the UK, where they were playing a quantum magnetometer to measure the heartbeat of the cows. If you are able to see when the cow is happier, the cow is going to give you more milk. More milk, more business, because this is a huge business in some countries around the world. Being able to measure the happiness of the cow can give you some clues on how to have more milk and better milk. This is a use case, but obviously you can use magnetometers also to measure the waves in your brain, and this can change healthcare. There are already some small prototypes of all these that you can use. It goes from a big magnetic resonance imaging and things like that to very small things that you can put on your head, and this will change medicine in the coming decades. And another one that I thought is interesting, because a lot of people don't see as ready as it is, because it's actually already in the market, is this radiometers and gravimeters, where you can map the underground. And I don't know in Latvia, but there are some countries in the world where it will be very interesting to know the resources that are underneath the ground to detect water, to be able to detect minerals and things like that, because this is a big geopolitical matter right now. So a lot of different things that are happening already now with quantum sensing. And then, of course, we have the quantum communication and security part. We know the potential of quantum computers, but we know that they will also pose a threat on our cryptography, because our cryptography right now, our encryption, is based on a mathematical problem that right now we cannot solve with classical computers. But there is an algorithm, Shor's algorithm, that demonstrates that a quantum computer can actually solve that problem. We have a quantum computer that is able to solve that. All our encryption is gone. We cannot send money through our bank without being hacked. We cannot ensure that our data is protected. So this is really, really important right now from our big data world, obviously, and now with AI even more. So a big preparation for governments and businesses in terms of quantum security is really, really key before quantum computers are ready. But on top of that preparation, there are different technologies based on quantum security and communication that it can give you more randomness, quantum random number generators. You have the infrastructure to be able to send information securely with quantum key distribution. And there are then the algorithms that are not quantum per se, but kind of give you a layer of security to all the algorithms that we have right now for encryption. And if you're not aware, there are already standards out there from NIST and from some countries that they give you the roadmap of what to do to prepare for this quantum security readiness. And that's kind of the glimpse of different use cases for quantum technologies. I think first, it's going to be disruptive. It's going to change a lot of things. And by a lot, it means that all business sectors are going to be disrupted by that. How? Well, let's try to discover that together. But obviously, a lot of people already realize about that. And since 2013, with the UK putting money for quantum technologies, every month during the pandemic, and now every 3 to 6 months, a new country is launching their national strategy on quantum technologies. This figure has been our figure for the last, I think, 3 months ago, we were using this figure. Just last week, and you're going to be the first one to see it in a talk, last week we launched our updated version. And we have changed the layout because it's becoming crowded, and it's really, really interesting to see how much global effort from public funding from the governments is put into quantum technologies. It's true that some countries have not announced a national strategy yet. It's the case of Latvia, but maybe we will hear soon. And I know that you will hear later from our colleague from Finland, and they are planning also some very interesting things that they launched in the news recently. So the countries are not only putting money, but they are launching a strategy, and they are thinking about that roadmap to be able to prepare for quantum technologies, because they are coming, and we need to work globally and together to cope with the new technology, with the new market, and with the new talent that is going to be needed for that market. If we look at the different quantum companies per region, most of them right now are in Europe. And I think that's very, very important, because if you're in Europe and you're looking for jobs, it doesn't mean that you don't need to go to the US as maybe it was in the past if you wanted to work in tech. But it's true that it depends on which country and where you want to work in. And here we look at the distribution of companies per country. Again, I don't know where you're coming from, but if you're coming from some countries, then maybe you don't even know that there is a company in quantum in your country. So I think that's very important. There is a company registered in Latvia. Did you know that? So it's true that there are a lot in the US and in the UK, Germany, France, but it's growing, and there are more and more opportunities. And the other thing is about what these companies do. Not all build a quantum computer. That's obviously not the cleverest, the most clever idea, but they are, most of them, working on quantum computers somehow. So it could be on the hardware side, or it could be doing software and algorithms. But it's true that you could work in other things. You could work in quantum security, sensing, or enabling tech, and that is lasers, cryogenics, and even end users. You could work for a bank that is looking at applications of quantum. So the quantum landscape, when we look at quantum computing, is really, really rich. This figure is from nothing last year, but this is just an example of how rich this could be. Because you look at the users, you look at the applications, you look at the components, and in these layers, you have different companies around the world working on that. So again, if you want to work for quantum computing, there are a lot of possibilities. It's not just IBM and Amazon, as sometimes people mistake as the only solution to working in quantum. But that's the next topic. That is, I don't know the time. That is the quantum workforce. And it's true that over the years, this has become a big topic. People start to talk about how needed it is to have talent that is ready for the supply, the need of quantum tech specialists. But at the same time, you have more and more people that they start to get trained in quantum, and it's the case of a lot of people that have done the training done in QWall, for example. But because they are not yet experts and they don't have a PhD, they still don't manage to get a job. So it's kind of we are working in that there is a talent shortage because the supply is not really fitting in what the demand is asking for. But this is going to change. And I would just say, don't stop learning, because again, it might be that now they are looking more at PhDs and experts, but this will change in 1 year or in 2. Again, because we are early in this quantum jobs market, we are going to be looking at more and more jobs that are going to be needed in the coming years. So this is going to grow exponentially in the coming 10, 20 years. That means that there will be a lot of people needed. The same that right now, people cannot find AI specialists, because you need AI specialists everywhere, but the demand is just too big and there is not enough people. What we are trying, and EIT and the European Commission is trying, is to look at what could be that need in digital skills in general, not only in quantum. How can we prepare European citizens, the people looking for jobs in the coming years, to be able to cope with that demand. And I think that is clear. It has to start with education of the people now. That means upskilling, reskilling, professionals that are starting to look at quantum, but also the workforce of the future. People that maybe are doing undergraduate programs, how can they prepare to be the experts in quantum in the coming years? This is really, really important. And this was from 2020. Then we did this other paper where we look at the different career pathways. Because it's true, a lot of people came to us. We were offering recruitment services. People were coming and say, I did a bachelor's in physics. Why I cannot find a job in quantum? Again, because most of the people, they require more specific and expertise in some skills. If you are building a quantum computer that is based on ion traps, even if you have worked in cold atoms and not in ion traps, they might not hire you. This is where we are, which is really, really hard. Because obviously, how many people work with ion traps in the world? Not many. People need, when I say people, quantum companies need to understand that skills can be transferable. That someone that has worked in cold atoms experiments could work building an ion trap quantum computer. And the same goes with algorithms. I have met a lot of people who are coming from more fundamental science, more looking at quantum physics foundations, and they said, hey, I'm looking for a job. Yeah, but you have not done quantum algorithms, which is true. Now, there are some bridges out there. For example, tensor networks is a technique that some people might have applied during their studies that can be transferable then to quantum algorithms. Or if you have worked in a lab where you look at, you have gained some expertise on lasers, for example, you can transfer that to almost any kind of hardware platform. See, there are a lot of things that are transferable, and I think Europe is looking up to that, and there is this competence framework that is very, very important now, looking at those skills. The truth, again, is that right now, just with a bachelor's, it's very hard to land into a job in the quantum industry. But it's okay. You're not in a hurry. You can go to a master's, you can do more training, or you can gain industry experience. I think in the coming years, it's going to be more about having that kind of business and industry experience more than actually a PhD into some topics. But I hope that helped you a little bit go into those different directions, depends on what you have done. And when we look at skills, the truth again is that it's not just about having a physics degree. That is not going to be the answer. It's more about having skills that you could use depending on the job. If you're going to work for a chemical company or for a quantum company or working on algorithms for chemistry, obviously maybe a chemist is going to be much better fit than a quantum physicist. The same for people that are coming from computer science. I think people that are coming from computer science and engineering are going to be the ones that are going to be much faster catching up on the coding skills for quantum computing, because you don't need to know the physics behind. You need to know more the coding skills that you gain with that. So I think this is going to be changing a lot in the coming years, and it's what some people call quantum engineering as a new field that is going to be needing more and more people around the world. And one important thing is, don't forget the soft skills. Don't forget all the things that are going to be the differentiation between your CV and any other CV. A lot of people do physics as a bachelor's. A lot of people can do a master's degree in quantum. But what has you done that is different from other people? Have you done anything about education? Have you done anything about an internship in industry? Have you demonstrated that you have different skills than someone that just studies something? And I'm pretty sure that everyone has something. Sometimes you just put your academic path, and remember, if you are going for industry jobs, we don't want to know about your paper. We want to know about your skills that can apply for the job. And that gives me also the other important thing here is that not only technical jobs are going to be needed, there are more and more jobs right now where they are looking at people with a bachelor or a master's in quantum, but that are able to talk, that are able to be the face of a company, going to an event and talk and say and do the sales of the product. That's not easy, because obviously a technical person has a set of skills that are not the same that a salesperson has. So being able, if you are good at that and you like that, being able to do customer relationship, sales, business development, that is something super, super needed at the moment. So a lot of questions is, where should I start looking for jobs and anything? I think just stop, sit back, and the question is not where to start, is where do you want to go? What do you want to do? And I'm going to give you an example of someone who came and he was an experimental physicist. Very, very important set of skills that you can use in a lot of different jobs. And he said, I want to go into quantum computing. I need to start programming. And I say, why? Oh, because if I want to work with a quantum computer, I need to code. And I said, do you want to code? Do you like to code? And he said, no, I like to be in the lab. Then why don't you work in the lab building a quantum computer? He didn't even think that the set of skills that he acquired could be applied for the job that he wanted to do. He thought that going into quantum computing meant just to code. And again, you can work in quantum, not even doing technical things, as I just said. Just think about what you want to do in that case. And the big question sometimes is, do I really need a PhD? And the answer is, it will depend. It will depend on what you want to do, where, and well, in what field. But if you're in Europe, it's true that because companies, in the development of the companies and the amount of money that investors put on that, in Europe, we are a little bit less developed than maybe in the United States. So it's true that most people look still for talent with a PhD, that expertise. But again, this is changing. And doing a PhD just because you think that is what you need to do, I will think twice. But if it's really what you want to do and you love the topic, just go for it. Because again, if you don't go for a job tomorrow, it could be after your PhD. There is not a rush to go into the job market. And the last thing I want to mention today is about some tips for your CV, because that's key. Today, even with AI, even more, your CV has to be tailored to the job you want to apply for. Your CV is going to be different if it's for academia, if it's for a PhD, or if it's for industry. It has to look good. Please check the design. It has to be good. The keywords on the job profile needs to appear in your CV. You need to have a LinkedIn profile, because most of the jobs you're going to apply directly on LinkedIn. And it's very easy because there are templates everywhere. You go to Canva, 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 and you have templates for free that you can download and make your fantastic design for your CV. Photo or not photo, I think it doesn't matter, to be honest. It depends if you want to put it or not. But you need to have that kind of your experience at the top, then your education, and your skills have to be really clear. But the most important, you see at the top, where your name, profile, you have that kind of small paragraph. This is me. This is what I have done. This is what I'm looking for. Those 2 or 3 sentences are key for your CV to be matched to the job. I think that's it. I'm going to shut up now. But if you want to be part of the quantum community, there are so many things that you can do. You can obviously attend all the different events and do all the courses that we have in QWall and in Cureca, but we have a lot of different things out there. This year is the year of quantum. It's really non-stop of events and opportunities. So please don't stop just being part of the quantum community. I think you being today in this event, either in person or virtually, that's a first step. So with that, I just want to thank you all again. Sorry that I cannot be there in person, but if you have any questions, you can reach me anytime. Thank you.
Yeah, thank you, Araceli. I think we can get one question maybe. And if there will be more questions, they can write in the chat. Araceli can reply later. Okay, I think there is no specific question.
No questions in person?
Okay, there is one question. How to start journey from the bachelor's degree itself?
Yeah, well, again, it depends what you want to do. I would suggest if you have a bachelor's degree to go into probably a master's for quantum tech. Again, in our website in Kureka, you have a link to all masters, and we are updating this. There are a lot of masters around the world. You can do it in person or remotely, but the masters has to be matching what you want to do. There are some masters that are more focused on quantum computing. There are masters that are more on quantum communications, and others that they give you that kind of overview. There are some more technical than others. It's really, again, think about the different technologies. Think about the different uses, the vendors, the users. Where would you like to steer your career, and then go into that. But I would go with a master's. Probably just with a bachelor's, you won't get a job. But well, there is still time.
Okay, there is a question about being part of community. I think now there are also several local communities. I can suggest to check, especially you can check Keyword. They have several local groups. Probably it would be the best to check them and then just communicate. And any internship also, there are several like companies like Keyword also offer the internship. We can share the link, but I don't know the deadline is already passed for this year or not. They ask about master in quantum technologies. I think now there is DGQ project. Maybe I can write.
Yes.
Under DGQ, several like quantum technology master established now. Probably they will continue. Maybe 15 universities. Now we are forming kind of quantum academy, and probably there will be more in Europe. At least I am aware of. Okay, we can try to answer the other questions later.
I will answer in the chat directly to the people who pose a question to me. I will answer directly and put my email if people want to reach out. Thank you,
Yeah.
Abu.